Hey everybody, today we'll do another math problem, and today we will do another problem out of this book, and basically that is going to be number 3 on exercises 9.1. Number 3 in exercise 9.1, which is basically integration. And we will do another problem, which is integration by part. This is going to be a little more complicated than the other one that we did in the last video. Not in the last video, but I will say about 3 months ago, I uploaded one video that was integration by parts. So this one is going to be it's more complicated. So again, we're doing integration by part. Okay, so that's what we're doing, right? And because I need a lot of room for this, I'm going to erase this. So the problem is as follows. The problem is like this. So the problem is x squared e to the 3x dx, right? And of course, as you can see, this doesn't have a limit of integrations, so therefore it's an indefinite integral, right? So here what we'll do is the following. So let me write it in this corner so I have a little more room. Let me write it right here. Let me just do it right here. And it's x squared e to the 3x, right? dx, right? So the complicated part of this problem is that we have an x squared here. So we have to integrate that twice. If we did not have, if there is only one x, we will have to integrate just once, but because we have an x squared, we have to integrate the twice. We have to do it twice. We have no choice but just do it twice. Okay, so we let u equal to x squared, and du is equal to 2x dx, right? Okay, so we have that, and then we let b db actually, yes, db equal e to the 3x, right? Integrate on both sides of that one, and we get b is equal to e to the 3x over 3, right? So we have this one, right? And also we have du, which is this one, right? So we have a du, and we have b, right? So, and also we have a u, right? So, because we will need all those terms, right? So what is that definition, right? The definition of the integral by integration by part is the following. So we have a u dv, right? u dv equal uv minus the integral of v du, right? So that is the definition of the integration by parts. Okay, so we have that, we have it now, we have a u, right? We have b, and we have a du here, right? So we actually covered that, right? Okay, so let's get started. So let me just write this up there so I get a little more room, right? So let's raise the part and write it, because I need some room, right? So let's do it right here. Let's do that v is equal to e to the 3x over 3, right? And du is equal to 2x dx, right? So we have this, right? So we have this 2, right? We need that. We need those. Okay, so we have those. Now let's plot everything in, right? So let's plot everything in the integral. So we have, in the integration by part formula, we have a u, right? And u is x squared. V is e to the 3x over 3 minus the integral of e to the 3x over 3 and then du, which is what? Is 2x dx, right? So we have that. Now, let me factor out here 1/3 out. When I factor out 1/3, right? Let me do it in black because I don't think this color is good. It doesn't look good in the camera. For some reason, this color, the camera cannot focus good and doesn't look bright. It looks very blurry. So let me just color black instead. Okay, so let me factor out 1/3 out, right? 1/3 x squared e to the 3x, right? Minus here. Let me factor out this 2 out, right? This 2 comes over here, and this 3 comes over here. So it's going to be 2/3 integral of e. Now look at this. So now I have an x here that also is hanging here. So okay, so this x, I will write it in front of the e. X e to the 3x dx. Okay. Now the first integral is done. Technically, should have a C like this, right? You can call that C1 because it's technically the first integral is done. Now, but the integral, this is not complete yet. Why? Because I have an x here. I need to get rid of this x. So I have to integrate one more time, at least, right? So what we do, we will do the same thing, right? So like I say, this C, you don't have to worry about it right now. We can do that later because it's going to be a constant anyway. So C1 plus C2 is going to equal C anyway. So we're not going to worry about that one right now. So let's let u again. U is equal to x. Du is equal to dx, right? Now, dv is equal to e to the 3x, right? Right? So when I integrate that, I get what? I get v is equal to what? It's equal to the same thing, which is going to be e to the 3x over 3, right? So now I have that, right? So now I have that du is equal to dx. So du is equal to dx, right? And v is equal to e to the 3x over 3. So we also need that information, right? We also need that. Okay, so now what I will do is the following. Now in this case, I already got rid. Notice that I already got rid of the x. So this x right here, not gonna exist anymore. Why? Because I already got rid of it. Du is equal to dx. So basically, this dx is sitting right here already, right? So what I will do is the following. I will integrate this, right? And I will put parentheses around, or bracket. I will put a set of brackets around this so I don't make a mistake, right? So I do it like this. I do 3x squared e to the 3x minus 2/3 minus 2/3 minus 2/3 minus 2/3, right? Now, how do I integrate this? Well, I have to follow the formula. Again, I will follow the formula. So how do I follow it? Well, step by step, we will do it. So our goal right here is to teach you guys step by step how to do things. It's very easy to make mistakes. Very easy. A problem like this is very easy to make mistakes because you got a lot of stuff going on. This is not a simple problem. It's not a simple problem. So we have the following. We have what? We have x, right? And why x? Because u is equal to x now, right? And then we have v, which is v is equal to e to the 3x over 3, right? So e to the 3x over 3, right? Minus what? Minus the integral, minus b du, right? So we do minus the integral, which is b du, right? And then we have 1/3 sitting in here, right? 1/3 sitting in there, right? So we have 1/3. I'm sorry, 2/3. I'm sorry, 2/3 sitting right there, right? Then what do I have here? Well, here this integral, I just have a b, right? B is equal to e to the 3x, right, over 3, and then dx, right? Okay, so Notice that I could actually factor this 1/3 out. I could do that, or simply take the integral of that and move that down. Either way is valid, right? So let me just erase that. Just erase this. So let me rewrite everything back here. Let me just take the integral of that right now so you can see it. Actually, no, let me just write it down here. So it's 1/3, 2/3. Is 1/3 x squared e to the 3x minus 2/3, right? 2/3. 2/3 x e to the 3x over 3, right? Minus the integral of okay, so minus the integral of, actually, no. Nope. I don't need the 2/3 here because I already did here. I don't need that. Right? So it's just the integral, right? I already factored it out, so that is multiplied through, so I don't need it. Okay, so we get what? We get e to the 3x over 3, right? And dx. Okay, I'm going to integrate this one right now, right? To get rid of this integrand sign, right? So I do have 3x squared e to the 3x minus 2/3, right? Minus 2/3. When I integrate that, right? That becomes what? That becomes what? This stays like that, x, right? And then e to the 3x over 3 minus what? Minus the integral of that, which is going to be what? It's going to be simply e to the 3x over 3 times times 3, right? Now I am multiplying this, right? Because I brought that 3 down, right? And then after I do that, this is equal to what? This is equal to 1/3 x squared e to the 3x minus 2/3 minus 2/3, right? Minus 2/3 x e to the 3x over 3 minus what? Minus 9, right? Minus 9 here. When I multiply 3 times 3 is 9, right? So e to the 3x over 9, right? So e to the 3x over 9. Okay, so now I need to do one more steps, right? I need to distribute this across here, right? So this is equal to what? This is equal to 1/3 x squared e to the 3x minus. See, I gotta distribute that, right? So this is going to be negative and this is going to be a positive, correct? So minus, when I distribute that, is going to be 2 is going to be 2x e to the third x over 3 over 9. See? This is over 9, right? Why? Because I am multiplying this 3 and this 3. So it's minus. So basically, I'm sorry, it's just 9 right there. Right? Okay, but I multiply those right there, the 2/3, right? 2/3 across, I get what? I get plus. Right? So I get plus what? I get plus 2e to the third x over what? Over 27. Right? So now, this looks like fairly an answer, but we can simplify this further and to get a cleaner answer, right? So what we can do is the following. We can actually multiply this by the greatest common denominator here is already here, 27. That is the greatest common denominator. So we can actually find the common denominator by multiplying this by 3 and this by 9, right? So we will do that. We will multiply that 3, right? And then 3, right? So I'm sorry, there's going to be 9 here. So it's 9, right? So we multiplying 1/3, right? We're multiplying 1/3. Okay, so we're multiplying 1/3 x squared e to the 3x, right? Minus what? Here we'll be multiplying by 3 top and bottom. 3, right? And that is going to be multiplying what? Multiplying 2x e to the 3x, right? Over what? Over 9. And then plus what? Plus 2e to the 3x over 27, right? Now when I do the math, what's going to happen is the following. So I multiply that, right? Is equal to 27. That is equal to 27, and that 27 is already there. So it's going to be what? It's going to be 9x squared e to the third x over 27 minus 6x e to the third x over 27 plus 2 e 2e to the third x over 27, right? Now look at this. Here I can factor out a stop, right? I can factor out 1 over 27, right? And that 1 over 27, if I factor out 127, right? But also I want to look what else I have in common. What else do I have in common? I got an e to the third x in every single term. So I can factor out also e to the third x, right? So which is going to be what? It's going to be that e to the third x is going to come out on the top here, and it's going to be what? It's going to be e to the third x over 27, right? Right? And I put parentheses, right? When I put parentheses, I said what else doesn't have any factor? Well, you will say that 6 and 9 have factors, yes, but 2 doesn't have a factor. So it doesn't matter. I can try to factor out this 2, but this doesn't have a factor. So therefore, this and this have a factor, but this and this 9 cannot be divisible by 2. So therefore, the only factor I have is e over 27, right? So this is going to be inside the parentheses. This 9x squared, the 6x, and the 2 have to sit inside the parentheses. So therefore, the answer is 9x squared minus 6x plus 2, right? Remember that we integrating, and that integration, so because it's indefinite, integral, we have to add a c, right? And we add a plus c there, right? And that is the answer. That is the answer for this problem. So as you can see that that it is very easy to make mistakes because there's a lot of algebra, it's a lot of factoring, a lot of taking into account that you factor out 1/3, and you got to keep out 1/3 outside the bracket. So this is a little more complex problem. But this is the answer for this problem. So if you like this video, if you learned anything in this video, give me a like, subscribe, and share. Thank you for watching. And again, we are the Conservative Engineering Academy. We believe that Jesus is the one that giveth us the knowledge to learn something every day. The Bible says, without me, you cannot do anything. So therefore, that's why we call it the Conservative Engineering Academy. Thank you for watching.